Hello again. I'm shortly going to be doing a clutch service on the 500 Morini I've been working on. You'll sometimes hear people say that the dry clutch on a Morini is inherently a bit grabby. Well, as far as I'm concerned, they're not inherently grabby. When they're set up right, they should be smooth as silk. I've done clutches myself and a few other people, and they've quite often commented on how nice they are afterwards. Now, with one of my Morinis, I think maybe the third one I bought, I inherited a whole bunch of homemade tools, and one of them was this little tool for unscrewing the clutch spring retaining sleeve nuts, and just grabbed a clutch off the shelf. Now, these aren't screwed home, because normally the end of the stud will protrude slightly beyond the end, or at least level with the sleeve nut. And you know, this thing's been sawn and filed, or possibly just sawn, and although it works, it hasn't been the best tool. I sometimes fight with it a little, and I decided that I really ought to make a proper tool for the job. So I've come in, and the studs are 7mm. There's quite a few 7mm metric threads on the Morinis. It's a bit strange in some ways that it was left out of the original sequence, as it nicely fills a gap between the 6 and an 8. You know, 8's quite often a bit bulky, 6 is a little bit on the small side and the weak side. So 7's fairly popular with Japanese, Ford use it a bit, and there's quite a few on the Morini. So I've had a bit of bar in the lathe, faced it, drilled a 7mm hole partway down the centre for clearance on the stud, and the next thing I'm going to do is move it over to the mill and machine it up to get the two dry flats. Now I'm going to be using, as I usually do, an auto lock style collet chuck, which uses screwed shank end mills. Now, these don't seem to be at all popular in the US, though they're pretty common in the UK. And I've got an end mill here, and another comment for our American friends. If I can stop knocking the tripod. If it's a 2-flute, we tend to call it a slot drill. If it's a 4-flute, it's an end mill. And I've just got it, just break it apart. Screw shank screws into the collet. Screw the end mill into the collet. Feel for the drive dog. Screw the nose cap on, and I will then screw in the end mill, and it bottoms out on a centre at the back of the chuck. And I'll unscrew the nose cap a little, tighten the end mill into the collet, and now all I have to do is give that a tweak by hand. If the cutter rotates at all, it tightens into the collet, pulls the collet forward and tightens the collet, so these can't slip. And because they bottom out on a centre, the cutters go in dead to length. So whatever, if you know, if you were using it on CNC, you'd always know that the end of the cutter was the same relationship in the chuck. Okay, let's get us realigned on the camera a bit here. Bring the knee up. Actually, let's have some power to the mill at this stage. Okay. see where we are for speeds. Okay, we're in high speed. And we're running in the right direction. So first thing I'm going to do is touch off against the end of the bar. Now I'm just going to do this fairly crudely by, just bringing the cutter in until it actually touches. Okay. Zero the Duro. Now I've measured the depth of the groove in the end of the nut, and I'll just go back and check it. Yeah, we've got 2.5mm. So cut a little clearance. Come into 2.5. We can lock that access. And now I'm going to just kind of come down and touch on the top of the bar and zero the Z. Okay. Now the bit of silver steel I've got here is 1/2 inch, 12.7mm, and I know that the slot in the screw is 2mm wide. So half of the 12.7 would give you 6.35. To get to the halfway line, the 2mm wide is obviously going to the 2mm wide divided by 2, 1mm. So we come down to a total depth of 5.35. We'll know that we're going to get a 2mm wide tank, and then I'll take that down a shade more for clearance. So I'll jack the knee up 0.5mm for the first cut. Some lube off the milk of the lathe. Another 0.5mm. Okay, we just come up on 5mm, and we said we wanted 5.35. I don't want to narrow the teeth slightly, so I'm going to go to 5.36. Okay, I've just come around the other side so that I can show you how I'm going to get this indexed 180 degrees. And went in the tooling cabinet and grabbed out some V-block and clamp. Just going to slip that on. I'll actually start at the inverted position. Use a square to set that up. And we'll just loosen the vise. And keeping it down onto the parallel. Run it round. And square it up. Traditional, phone always rings. Well, after a little bit more work on this thing, I cross-drilled it for a handle, hardened and tempered it, gave it a little polish up. We have one really nice, easy to use clutch tool.